So here's an example. We're given a PDF, and it gives us 6 different things that we can find from this PDF. So let's go ahead and get started with the very first one, and that is, let's find the constant k. So to find the constant k, the principle we're going to use is that the integral of the PDF over the range of x is equal to 1. So in this case, the integral of this function should integrate to 1. So let's go ahead and take the integral. So this is going to be negative 2x to the third, and we bring that 3 down below, plus kx, add 1 to the exponent, that'll be 2, and then bring the 2 down below, plus 1/6 x, evaluated from 1 to 0, should equal 1. So when we put 0 in, that'll all cancel out, so we just really got to put 1 in and see what we get. So we get negative 2/3 1 cubed, plus k over 2, 1 squared, plus 1/6 times 1. And then there, just to let you know, this then should be minus negative 2/3 0 cubed. And we'll keep going from there. But that's all going to be 0. And that should equal 1. So here we get negative 2/3 plus k over 2 plus 1/6 is equal to 1. So we can add a common denominator, minus 4/6 plus 3k over 6 plus 1/6 equals 1. Multiply by 6. So we get 3k minus 3 equals 6. 3k equals 9. So therefore, k is equal to 3. So that is the answer to part A. So just to then formalize it, is f of x is equal to negative 2x squared plus kx, so plus 3x, plus 1/6 for the values that x takes on between 0 and 1. Okay, now for part 2, let's find the CDF. And remember, the CDF, big F of x, is equal to the integral from the lower bound, we'll represent by infinity, up to the value of x, of f of x, dx. So finding the CDF, right? And sometimes in the notes, we call this f tilde. There just to let us know it's a different x than the one that's in the integral. So this is the integral. The lower bound is going to be 0 up to x of minus 2x squared plus 3x, let's call this x tilde, plus 1/6 dx tilde. And then we can take the integral, and that is where f of x is equal to negative 2/3 x cubed plus 3x squared plus 1/6 x. And that's because we put in that x, we put in 0, and that's what we get. So there is our CDF. Now with the CDF, let's go ahead over here and look at question 3. Find and interpret the probability of 1/2 less than or equal to x less than or equal to 3/4. So what we're asking here is, the setup of the question is this x represents, or the function represents the stock in a warehouse. So we're asking, what's the probability that the stock of the warehouse is between 1/2 and 3/4? So what I can do is just use the CDF, and I can look at big F of 3/4 minus big F of 1/2. And so this is going to equal, so I take big F of 3/4, so minus 2/3 3/4 cubed plus 3/2 times 3/4 squared plus 1/6 times 3/4. So that is big F of 3/4 minus, and now in brackets, I'm going to have negative 2/3 times 1/2 cubed plus 3/2 1/2 squared plus 1/6 times 1/2, like that. And then as you go ahead and simplify and solve, break out your handy dandy TI-83 Plus calculator, this will equal 5/16. So we would interpret this as the probability that the warehouse is between 1/2 full and 3/4 full is 5/16. Now let's go on the fourth question. The fourth question asks, what is the mean? Well, remember the mean, the expected value of x is equal to the integral of x, f of x, dx. And that is analogous to what we had for the discrete case, where the expected value of x is equal to the summation of x times f of x. So in this case, the way it relates is that integral is a summation, our x is there, and our f of x is there. So it should be fairly similar to what we did with the discrete case, but this is the continuous case. So in this case, the expected value of x is equal to the integral over 0, 1 of x times f of x dx. And so this is equal to the integral of 0 and 1 of x times negative 2x squared plus 3x plus 1/6 dx. And so now we'll get integrals from 0, 1 of negative 2x cubed plus 3x squared plus 1/6 x dx. Now let's go ahead and take that integral. So we're going to go negative 2x. We're going to add to the exponent and put that underneath. And then we're going to get 3x, add to the exponent, put that new exponent underneath, plus 1/6 x squared, and put that 2 underneath. And that's going to be evaluated from 1 to 0. Now you're saying, well, don't we need the constant? Well, we do, but we have a definitive integral here, so we're going from 0 to 1. The constant will cancel itself out. So now we put 1 in, the 0 will cancel out, and this will give us negative 2/4 times 1 to the 4th plus 1 times 1 to the 3rd plus 1/3 1 squared, and this equals 0.583. Okay, now let's go to find the variance of x. Okay, this is 5. Or actually the standard deviation, but let's remember the standard deviation. So let's erase that. So we can do the variance of x, but let's go ahead and say the standard deviation of x is just equal to the square root of the variance of x. And then the variance of x, the equation we know, is equal to expected value of x quantity squared minus expected value of x outside squared. So now we need to do the expected value of x quantity squared is equal to the integral from 0 to 1 of x squared times the function, which is negative 2x squared plus 3x plus 1/6 dx. And so now we're going to take that integral and we can go ahead and solve it out. So this integral is equal to, let's first go 0 and 1 of negative 2x to the 4th plus 3x cubed plus 1/6 x squared dx. And so now we'll get negative 2x to the 5th over 5 plus 3x to the 4th over 4 plus 1/6 x cubed times 3 evaluated from 0 to 1. And so this will equal negative 2/5 plus 3/4 plus 1/18. And that is the variance of x. And so we'll now take the square root of that to find the standard deviation, and that will equal 0.26. So there we found the standard deviation of x. Now we just need to do one last thing, and we'll do it over here. We want to know the expected value. So this is number 6. Expected value of 1,000,000 x plus 100,000. Well, this is easy because it's a linear operator, so this is just 1,000,000 times the expected value of x plus 100,000, because the expected value of a constant is just a constant. So now we take the expected value of x, which is 0.583, plug that in for the expected value of x, and we can then plug and chug to find that the variance of the expected value of x is 680,000. So this is the expected value of x. And now we could also do the variance of x. So the variance of x is equal to the variance of 1,000,000 x plus 100,000. Well, this would be 1,000,000 squared times the variance of x plus 0. And now we're going to take the variance of x is equal to you can do it here, is equal to 0.26 squared. Put that in. Or we can just say take the square root of the variance of x, which would equal to the square root of 1,000,000 squared times 0.26 squared, which is equal to 1,000,000 times 0.26, and that is equal to 260,000, which is the standard deviation of our new x. So there we can put that in brackets. And there we've answered all the 5 parts of the question, or the 6 parts of the question. Let's go ahead and put this last part right here in a box that we asked. And so this is taking our PDF and be able to show that's a PDF, find the CDF, interpret the range of a CDF, find the mean, find the standard deviation, and then find the expected insurance payout, which might be a function of that variable of x, and find the expected value and the variance of that expected payout.